So let's look at an example of doing a confidence interval for a comparison of two different means in small samples. Alright, so we have this software company that markets a new computer game with two experimental packaging designs. Design 1 is sent to 11 stores. Their average sales the first month is 52 units with a sample standard deviation of 12 units. Design 2 is sent to 6 stores. Their average sales the first month is 46 units with a sample standard deviation of 10 units. We want to construct a point estimate and a 95% confidence interval for the difference in average monthly sales between the two package designs. Now, let's identify everything. First of all, X bar 1 is, let's see, average sales were 52. And S1, or standard deviation 1, was 12. And in this case, N1 was 11 stores that it was sent to. And then X bar 2 was 46 units, the average sales. And S2 was a standard deviation of 10 units, and the number in our sample was 6 stores. Okay, we're going to construct a 95% confidence interval. So recall, with all confidence intervals, we want to subtract this from 1 first, and then we have to divide this by 2, which gives us 0.025. Now, since this is small samples, we're going to have to use t. We're going to have to use our t function in Excel. But let's keep in mind that our degrees of freedom are calculated differently up here. So our degrees of freedom are N1 plus N2 minus 2. Well, let's see, N1 was 11, N2 was 6, and then we're going to subtract off 2. That's going to give us degrees of freedom of 15. So we're going to look up 0.025 with 15 degrees of freedom using the t function. So equal t.inv 0.025 15 degrees of freedom give us negative 2.131. Now remember, it's a confidence interval, so the negative doesn't matter. 2.131. So our t value here is 2.131. All right, now, before we go into doing this confidence interval, we've got this new calculation we've got to do first. This thing that looks like S sub p squared. We call it the pooled variance. And we've got to do that calculation so that we can plug it into our confidence interval calculation. So our pooled variance comes first, and I'm just going to write it that way rather than writing S sub p squared. Alright, so on the top of the fraction, we're going to have N1 minus 1. Well, N1 was 11. 11 minus 1 will be a 10 right there. Times the first standard deviation squared, so 12 squared. And then we have N2 minus 1. Well, N2 was 6, and 6 minus 1 is really 5. Times our second standard deviation, 10 squared. And then we want to divide that by N1 plus N2 minus 2. Now we already got N1 plus N2 minus 2 right here. It was 15, so I'm just going to put 15 right there. All right, so in my calculator, I'm going to do all of the numerator first. That gives me 1940, and I want to divide that by 15, so let's do that in our calculator, which gives me 129.33333. I'm going to take it out about 6 decimal places. All right. Now, let's go ahead and put all this information into our confidence interval. So, first things first. Now, we had to get a point estimate. Let's go ahead and get that. That's X bar 1 minus X bar 2. So, in this instance, 52 minus 46, our point estimate is 6. Okay? But let's go ahead and put that into the confidence interval formula. So notice our very first part of the confidence interval is the x bar 1 minus x bar 2, which we just got. So we'll have 6 plus and minus. Our t of alpha over 2 was 2.131. And now we'll have the square root of our pooled variance, 129.333333, and then we've got to multiply that times 1 over n1, which is 11, and 1 over n2, which is 6. And notice that set of double parentheses that I put in there, one of them for this part right here, which is in parentheses in our formula, and the other part for the square root, so that when we put this into the calculator, we get it right. I'm going to do that square root first. So that's going to give me 6 plus and minus 2.131 times, and I get 5.771753. Oops, except I can't type. All right, and then let's finish the multiplication there. So we'll have 6 plus and minus, and I need to do my 2.131 times the 5.771753. And I'll round that to one decimal place since my original data is to the whole number, so that's 12.3. And of course, now we need to do 6 minus 12.3 and 6 plus 12.3. So our 6 minus 12.3 is going to give us negative 6.3. And our 6 plus 12.3 is going to give us 18.3. All right, so our confidence interval is from negative 6.3 to 18.3. All right, so let's state our final result. We are 95% confident the true difference in sales, in average sales, for these two designs is between negative 6.3 units and 18.3 units. And there we have it.